All right, so hello, welcome back to the One Class live stream. Again, my name is Joey. I'm going to be your math teacher for the session. What we're doing here at One Class, if you're tuning in for the first time, is we're answering a series of secondary level math and chemistry questions. So these questions range from anywhere from basically pre-algebra all the way to calculus, pre-calculus. So if you're looking towards a stream that you can kind of learn in terms of material and keep up in school, this is definitely the stream to check out. Again, we're working for the Ontario curriculum. Basically, we're working from basically kind of grade 8 math all the way to university level and college math. So this is kind of what we're doing here at OneClass. Again, my name is Joey. I come from a background of being a secondary school educator, and I specialize in subjects such as chemistry and science, and as well as math as well. So, without further ado, let's get started. If you're tuning in for the first time, again, thank you for watching. And what we're going to do is we're going to I have a series of 10 questions for you for this hour, and it's going to hover around the grade 9 algebra and grade 9 geometry kind of courses as well. So we'll answer those questions and we'll go from there. So without further ado, let's get started for today. All right, so we have our first question here. States that triangle ABC is an obtuse triangle with the obtuse angle at vertex B, then angle A must be equal to. So let me just draw this out first. They have a diagram here, so let me draw this out. So it looks something like this. So something like that. I don't kind of like this line here, so I'm going to redraw it. Something like that. And they have A, B, and C, and this is question 1. Right? And we know that vertex B here, so B here is an obtuse angle. So angle B is an obtuse triangle. Is it an obtuse angle? So therefore, what can be said about angle A, right? So we're finding this angle here. Angle A is equal to what? Or what could be the possible values of angle A? So take a moment to think about this question. Again, think about what this word obtuse means, and think about what an obtuse obtuse triangle entails. So take a moment to think about this question here. So let me give you a couple hints here. So obtuse angles have an obtuse triangle has an obtuse angle. So what does an obtuse angle mean? So obtuse angles means that it means that it's greater than 90 degrees or between 90 and 180. So angles are between 90 and 180 degrees. So that's what makes an obtuse angle here. So knowing that my obtuse angle lies between 90 and 180, therefore I can assume that if you recall your sum of interior angles of a triangle, so sum of interior angles in triangle, so this also equals 180 degrees, right? So we have 180 degrees as our sum equals basically angle A plus angle B plus angle C, right? This is kind of our formula here. We know the angle B is anywhere between 90 and 180. So let me algebraically move angle B to the other side here. So it's 180 degrees minus angle B equals angle A plus angle C, right? And if we know this here is between 90 and 180, let's just assume that this angle here is 91, because it can't be 90 because it could be a right angle. So it's anywhere from 90 to basically 180 here. So in this case, this value is going to go basically below 90. So I'm going to say this will have to be below 90, and I'm going to do an inequality here, assuming that angle A, so this would equal, so angle A plus angle C has to be less than 90 degrees here. So this is 90 degrees, sorry, not 90 degrees here. So angle A plus angle C has to be less than 90. Therefore, what we can kind of conclude about this question is that angle A and angle C are both acute angles. So angle A and angle C are acute angles, meaning that angle A is less than 90 degrees. So it has to be less than 90 degrees for this to happen, or basically between 0 and 90. Let me rewrite this. So between 0 and 90 degrees. So that's kind of what we can conclude about this triangle. We aren't given any more information about this triangle other than that B is an obtuse angle, which means A and C have to be acute angles. Remember, acute angles have to be less than 90 degrees. So this here is my correct answer, or this here is my answer I got here. Angle A and angle C are acute angles, therefore it has to be between 0 and 90 here. So they got the solution here as well. Angle A must be an acute angle, that's correct. So they drew out an obtuse triangle here. Since we have angle B as an obtuse angle, therefore it must be greater than 90 degrees. That's good. So that's what I had here. It has to be greater than 90 degrees. As we know, the sum of all triangles is equal to 180 degrees. Therefore, angle A plus angle B plus angle C equals 180. That's good. This implies that angle A plus angle C equals 180 degrees minus angle B. So this gives us angle A plus angle C has to be less than 90 degrees. So this here is our equation here. Oh, so shoot. This here will help us. This here will help us with our answer here. The sum of two angles is less than 90 degrees. Hence, each of them will be acute angles. Therefore, angle A and angle C are acute triangles. So this here is correct. So solution is correct. Great analysis. So the solution here is correct. Sweet. That's our first question of the day. So this is question 1. Let's do question 2. Okay, so question 2 states that it says, oh shoot. 2 states that a function of the form f of x equals mx plus b, where m and b are real numbers, is called the what function? So if you have the form f of x equals mx plus b, where m and b are real numbers, or just say what function? So we have f of x equals mx plus b, so f of x equals mx plus b, where m and b are real numbers. So basically it's saying that they're basically, they have some sort of value. So m, if you recall from this function here, this function, it looks very much so like a linear function, right? Linear function here. So remember, if you recall from grade 9 math here, m here is our slope. And we can calculate slope either by rise over run, or we can use 2 points on the line and say y2 minus y1 over x2 minus x1. So we can use that to find the slope. This b here is our y-intercept, right? Our y-intercept. So whenever the line crosses the y-intercept, that is going to be whenever it passes through the x-axis there, you will get a y-intercept. So we have kind of those 2 points here, and it's saying that what is called the what function. In this case, it's a linear function, right? I have a slope, I have a y-intercept, and then f of x. You can also say this is y equals mx plus b, right? So this here can also be rewritten as y equals mx plus b. So we have x and y are just simply 2 points. M is our slope and b is our y-intercept. That's good. And so that so here we have a linear function. So another way to think about this question is that our degree of this x here is only 1, right? The degree, let me write this down here. So degree of x is only 1. And that's a really big giveaway that it's it's a linear function. If we had a squared term, we would have quadratic, and we have a cubic for 3, and so on and so forth, right? So it depends on what the parent function is in this case. And if it's only x here, degree of x is 1, therefore the only option here is a linear function. So these are all ways why we can figure out that this here is a linear function. Again, the slope, the y-intercept, and the degree of the highest order of the polynomial here. All these things give us a linear function. So let's see, m and b are real numbers. It's called a linear function. That's good. It is called a linear function because the highest power of x appearing in the expression is 1. That's good. Consider the two expressions here. So x squared plus 5x, both of these expressions are not linear because the highest power of x is 2 and 0 respectively. So that for expression of the form f of x equals mx plus v, where m and b are the real numbers, to be linear, it must be necessary, or it is necessary if the highest power of the x appearing in the expression must be equal to 1. This here solution is correct. Great analysis. So we can use all these terms, but really it depends on what the degree of the polynomial is. So therefore, it's a linear function. Okay, that's question 3. Let's look at, that was question 2. Let's look at question 3 here. It says, what is 1/3 in percent form? So what is 1/3 in percent form? So we can actually approach this, question a lot in terms of how we can actually convert this percentage, right? So you can do basically either percentage from fraction. So we have a fraction here. This guy is a fraction. So we can do from fraction to decimals into percent, from fraction to percent. Usually I would prefer to do fraction into decimal into percent because decimal to percent is a very easy conversion. So let's do that. So I'm going to go from fraction to decimal and then finally to percent. So in order for me to convert fraction to decimal first, I would have to basically do the division, right? I would have to divide 3. Instead of 1/3, I would have to do the denominator over the numerator to convert it to a decimal. So I would do basically a long division here and put 3 here, and then this would be 1 point, and then you would add basically 0, 0, 0, 0, 0, 0 here. And the decimal place is going to lie right over here, right? Because the decimal place is here, it's going to lie at the exact same place here. So I have 0, this is going to be 0 point, and then basically do long division, right? 3 times what will give me closest to 10. 3 times 3 gives me closest to 10. 3 times 3 here is 9. And then 10 minus 9 here is 1. I bring down the 0. Do the exact same thing. 3 times what equals closest to 10. 3 times 3 is closest to 10 without going over. Minus 9 over 10 minus 9 is 1. And as you can see, this kind of repeats itself, right? Again, if I bring down the 0, this is 3 times 3 again. 10 minus 9 here is 1. Bring down the 0. Exactly the same here is 1, right? So this here, as you can see, is a repeating decimal. So I can say that I can conclude from my long division that 1/3 equals 0.333, basically repeating 3's, right? So I'll just say 0.333. Therefore, then I have my decimal now. This is my decimal here. So how would I convert it to percent? Remember, if I have my decimal here, 0.33 bar, or 3 repeating bars, what I can do is I can multiply this decimal by 100%, right, to get rid of the decimal, and then to get a percentage. So 0.33, I'll do 33 times 100% would give me, multiply by 100, I can move my decimal place 1 and then two steps here, right? So this would equal 33%. Or if you want to be even more accurate, you can say it's actually 33.3 bar percent, because I know my 3's are a repeating figure in this question here. So this here, both of these guys are acceptable answers in this case. So 33% or 33.3 bar percent would be my solution here. So let's see what we have. There's a solution from Princeton University. Percent represents parts of a number out of 100. That's good. So what they're doing is if a quantity is given in a fraction form, then you can just multiply the quantity by 100 to find the equivalent percent of that quantity. Half can be converted into percentage form by multiplying half by 100. That's good. In the given case, you have to convert 1/3 to its percent form, so multiply 1/3 by 100 to give you that. So this works as well. Like I did a more complex way, and I did fraction from decimal to percent, but you can also do from fraction to percent, right? It depends on how you think about the question here. So this student, they did fraction to percentage directly. So I have 1/3, and then I'm simply just multiplying by 100%, right? So 1/3 times that here is going to equal 33.3%. So this here is also correct. This is also a correct way of figuring this out as well. So I'm going to say the solution is correct. Solution is correct. Great analysis. Sweet. So it was number 3. Nice. Let's work on number 4. Speeding by these today. Might be a short video today, which is good. So we have 5 boxes of bananas. So let me write this down. 5 boxes of bananas sell for $30. How many boxes can you buy for $9? Okay. So 5 boxes of bananas for $30, right? So I'm going to say basically 5 boxes. So I can write it down. 5 boxes would equal $30. It's asking how many boxes can you buy with $9? With that, or that's 9 o'clock. Sorry. How many boxes can you buy? Or so I'm going to say this is X boxes. How many boxes can you buy with 9? So this is a great question. In terms of it's talking about proportion, talking about kind of rate, and whatnot. So how do we solve for this problem here? So take a moment to think about this question. How would we solve for this proportion question? So it's asking us 5 boxes of bananas sell for $30. How many boxes can you buy for $9? So there's a couple ways to think about this question. We'll take a moment to think about this question here, and then we'll solve it together. I'll do some blue. So in order for me to solve this problem, what I'm doing is I'm going to do something in terms of I'm going to set a rate of the boxes. So how do I do that? So if I know that 5 boxes equals $30, then how much does it cost to buy 1 box? Let's see. So 5 boxes is equal to $30, which means if I divide both sides by 5, so if I divide here both sides by 5, we get 1 box would equal 30 divided by 5 is $6, right? $6 here. So if I know that 1 box is equals to $6, what I can do is I can simply just do a proportion, right? Proportion between how many X boxes equals basically 9 boxes here. So, $9 here. So in order for me to do that, I would simply just do, I would create like kind of an equation with this, right? I would say that this X value, I know, or I can actually do this by simply kind of inspection, right? I can say that if 1 box equals $6, then I have X amount of boxes, right? I'm going to subtract $6 from this question here, I'm going to get $3 left, right? So therefore, my box here is currently at 1. I have 1 box, right? But I have $3 remaining, right? So with $3, can I buy 1 box? I cannot, right? It costs $6 to buy a box, but I could buy half a box, right? Half a box would be $3, right? Half a box is $3 here, right? So therefore, I can say I can buy with $3 left. This here I'm now equal to 0. So therefore, I can exchange my $3 for half a box. So I can say with 1.5 boxes, with $9, I can buy 1.5 boxes. So this here, you can kind of do this inspection. You don't really have to set up a proportion, but you can kind of do this question by inspection, saying that, oh, if I have $9, if $6 is one box, then I simply can buy 1.5 boxes with $9 here. So the answer here is B. That's good. Let's see, B is correction since correct answer since 5 boxes sell for 30. We need to evaluate the number of boxes is 90. That's good. Selling price of one box is $6. That's what they wrote here. And $6 we can buy one box. So for $9 we can buy basically 9 divided by 6, right, which is 1.5 boxes. So this year what they did was they kind of set up this proportion here, right? They did this would be $9. So that whatever total amount divided by the rate, which is $6, equals basically it's one box for $6, and this would be X here, right? So this is what they're solving for here, and what they get, you can basically cross multiply to get you can get an algebraic equation. You get 9. You can cross multiply like this. You get $9 times 1, which is 9, times 6x here. You realize that 6 here equals 1.5. So kind of the same thing as what we did here, but you can kind of do a proportion like this to solve for your this. In this case, because the question is simple enough, you can probably just solve it through inspection. So this here's 1.5 boxes, which is the correct answer. Great solution and analysis. All right, that was question 4. Let's do question 5. So question 5 stating how many cups are equivalent to 1 pint. So it's kind of the same question as what we're doing from a previous video when you're talking about conversions, right? Measurement. So how many cups are equivalent to one pint? So how many cups are equivalent to a pint? Again, we're working in the imperial system here. This would be in the imperial system. And what we can do is we can kind of draw out like a schematic, right? We can say, remember our scales here for the imperial system. We have 1 cup. So we have 1 cup equals, this is 8 fluid ounces, right? 8 fluid ounces. We know that 1 pint equals 2 cups. We know that 1 quart equals 2 pints. And then 1 gallon equals 4 quarts, right? So we know all of these kind of empirical measurements for measuring this is volume, right? So what we can do is what do we care about here? We care about how many cups are equivalent to 1 pint, right? So in order for us to do that, we care about this guy here. So 1 pint equals 2 cups. Do this in blue. It says how many cups are equivalent to 1 pint, right? So actually, in this case, it's so how many cups are equivalent to 1 pint? So your solution here is correct here. It's just I have my solution here. How many cups are equivalent to 1 pint? 1 pint equals 2 cups. I don't have to do any kind of math here, just because it's by inspection here, right? I know this measurement from before. So the solution here, 1 pint equals 2 cups. We're good. So it says here, half of a pint, which is equal to 8 fluid ounces, or 16 tablespoons. Half of a pint equals 1 cup. Okay, but I need to know what one cup is, or 1 pint is. So a cup is defined by 0.5 pints, then 1 pint equals 2 cups here. So 1 pint equals 2 cups. So I don't think they stated the solution here. They just had half a pint equals 1 cup, but it says how many cups are equivalent to 1 pint. So they should, this here is the solution. This here is the solution. 1 pint equals 2 cups. I don't think they stated it clearly, but I think it's in there. So good solution, but didn't state clearly. And the 1 pint equals 2 cups is your solution. So I'll say the solution is correct, but like I don't know why they wrote half a pint equals 1 cup. That's not what it's asking what equivalent to 1 pint, not half a pint. So it's just it's kind of a big text here. I don't know what the story is. Starting from a gallon, which is bigger. There was a town called Gallonland. I don't know about the story, but you can say good solution, but didn't say clearly 1 pint equals 2 cups is your solution. So I'm gonna say solution here is correct, but there isn't like it wasn't very clear as to how they got as to where it was in the question, in the solution. Sorry. So okay, let's do number 6. How many nanometers are in 1 centimeter? Nanometers in 1 centimeter. So this is now working. We're actually working in the metric system now. This is the metric system. So we kind of have like we have a chart here, right? And actually, they actually have a chart here. So I'm gonna kind of use this chart to help us find this. So we care about a nanometer and a centimeter, right? So I'm gonna copy this chart here. It says unit here, and we have the conversion. And this is in meters. So we have a cm here, or one centimeter is equivalent to 10 to the power of -2 meters, because 100 centimeters equals 1 meter, right? That's good. And then a nanometer, or nm, equals 10 to the power of -9 meters. So therefore, what we care about is how many nanometers are in 1 centimeter. So we care about this conversion here. We're converting from these two units together. So whenever we have how many nanometers are 1 centimeter, if we want to go up the chart, we can see if we're going from a smaller unit to a larger unit, you're going to divide. If you're going larger to smaller, you're going to multiply. So this is from a smaller unit to a bigger unit, right? How many nanometers in 1 centimeter? So what we're going to do is we're going to simply take the difference of kind of these two units here. So for example, I have this is one meter equals 100 centimeters, right? And then 1 meter here equals, this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 1 billion nanometers, right? So what we can do is we can simply just divide these two numbers to get how many nanometers in a centimeter here. So we can say that if I know that 1 cm, I can simply just divide it, right? I can just do 1,000,000,000,000 nanometers over 100 centimeters. So again, I can say that this 0 cancels out, and this here cancels out, right? This is, or no, actually these two zeros cancel out here. So I'm left with 1, 2, 3, 4, 5, 6, 7, 8. I'm left with 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. So I have this is 100 million now. So 100 million nanometers would equal 1 centimeter. So 100 million nanometers would equal 1 centimeter. And this here is my correct answer for this solution here. Again, every time we go from a, if we're going like C in the solution here, we're going from a smaller unit to a larger unit. So we divide. If we're going from a larger unit to a smaller unit, we multiply. So as you can see here, we have, let's see, 1, 2, 3, 4, 5, 6. Oh, this is 7. Sorry, not 8. I miscounted my zeros here. 1, 2. Oh, no, that was 8, right? No, we're good. This here is 8. 8 zeros. Yes. 1, 2, 3, 4, 5, 6, 7, 8. Good. So you can say that. So what they're doing here is they're converting from basically centimeters to meters. So it's 10 to the negative 2. And we know that 1 meter equals 100 centimeters. That's good. And 1 nanometer equals 10 to the negative 9. Negative 9 here. Meters. So 1 meter equals whatever 1 billion nanometers. And basically what they're doing is they're saying that they're dividing 10 to the negative 10 to the 9 by 10 to the negative 2 to get 10 to the 7 here. So I personally don't like this this method here, because what they're doing is that actually no, this is okay. This is okay here, because they stated that 10 to the negative 9 or 10 to the 9 is equal to 1 meter. So they're basically converting all the meters, and they're converting to meters first before they're converting it to back to nanometers. So that's what they're doing here. So the solution here is correct, but they did 2 steps. They did from centimeters to meters and from nanometers to meters, and then what they did was they took these 2 conversions and then they multiplied here, which is the same thing as this here is actually divide, but they're multiplying by 10 to the negative 2 is the same thing as dividing by 10 to the power of 2. So this here is solution. The solution here is correct. 10 to the 7 equals 100 million. So this solution here is correct. Good analysis. Solution here is correct. Sweet. So that's number 6. Number 7, again, we have the same kind of measurement kind of question here. So let me zoom out and kind of do this question relatively quickly here. We have the exact same thing. I don't know if I can copy and paste, but let me see if I can do copy and paste. Nope. Can I hold this? No. So basically, I have this. I have the exact same kind of question here. It says, how many cups are in 2 pints? So I'm going to copy this. 1 pint equals 2 cups, right? I know that 1 pint here equals 2 cups. So 1 pint equals 2 cups. So it says, how many cups are in 2 pints? So I'm saying if there's 2 pints here, how many cups are there, right? So again, very, very easy solution. Again, if I have 1, what do I have to do to get from 1 to 2? I am multiplying by both sides by 2, right? So I have to multiply 2 from this side, multiplying 2 from this side, and then 2 from this side, right? So 2 times 2 obviously equals 4 cups. So 2 pints would equal 4 cups. So this solution here is correct. They did a big summary. Again, they used the exact same table like we said before. So therefore, it says 1 pint equals 1 times 2 cups. So 2 pints, we're multiplying both sides by 2, you get 4 cups. So in the answer, it says in 2 pints, there are 4 cups. The solution here is correct. So that's number 7. Very, very, very easy question here. So let's do question 8 now. We're breezing by this. It's only 10:34. That's awesome. So question 8 is, if a new shirt costs $34.99. So if a new shirt costs, this is $34.99, and the sales tax is $2.10, then the sale tax rate is, and then it's asking for that. So it's asking what is the sales tax rate for this problem. So take a moment to think about this problem. So this here, if a new shirt costs $34.99 and the sales tax is $2.10, then the sales tax rate is. So we're looking for a rate here. When we look for a rate here, we're looking for some type of division problem, right? Or a percentage, right? A rate is a percentage. The sales tax, for example, in Ontario is 13%, right? So it's a percentage of what you buy, right? So this here's a big giveaway as to what we're doing here. Let's take a moment to think about this problem. All right, so let's look at this problem here. So it says if a new shirt costs $34.99 and the sales tax is $2.10, then the sales tax rate is. So we know that we have $34.99 is our kind of a price of our product, right? Which is the shirt. So anything you buy, you have to pay tax on, right? So we're gonna multiply that by some type of I have a sales tax rate, right? I have some type of rate here. So I'm going to say I'm going to multiply by x, which is r. And I'm going to say let x be our rate. Oh, sorry. Let x equals sales tax rate. So it's a percentage of my product here, which is the shirt, and this would equal $2.10, right? So because I know the sales tax rate is that. So in order for me to solve for this simple equation, what I'm going to do is I'm going to move $34.99 to the other side, right? The moment I move this to the other side, and multiply, I'm doing the inverse operation, the opposite operation, which means I'm going to divide, right? So I have x here equals, this is $2.10 divided by $34.99, and this will give me a decimal number, right? So this is $2.10 divided by, this is $34.99. This here is a decimal, gives me a decimal of, this is here is 0.060. If I have a decimal here, what I can do is I want the percentage, right? A tax rate is in percentage. Simply, I can multiply this percent or this decimal by 100%. So I'm going to move 1 and 2, which means therefore the tax sales rate is here is 6.0%. So this here is my final solution for this problem, 6.0%. So let's see what they did here. Since the cost of the shirt is $34.99 and the sales tax is $2.10, now we have to find at what rate the sales tax has been taken. That's good. Let X% be the sales tax that has been taken. So they say X of $34.99 equals $2.10. They said X of $34.99. I just simply multiplied it. That's totally fine. This implies that X divided by 100 times $34.99 equals $2.10. That's good. And then now we're simply doing, they cross multiplied, I believe. Yes, they cross multiplied. So what they did was, let me just draw it out for you because it's not very, very clear what they did in this step. But what they did was, if X over 100 equals 34. Did they cross multiply? Oh no, they did not. They just simply moved everything. They moved everything to the other side. They didn't cross multiply. Sorry. So what they did here algebraically was, let me just write this down for you. So this is X over 100 times 34.99 equals $2.10. So what they did was they did two steps at once. So they first they divided here. So X over 100 equals 2.10 divided by 34.99. And then to move this to the other side, they multiplied both sides. So that's what they did here. Times 100. So that's what they did here. So you have, so that's what gives you kind of this value here, 210 times 100 divided by 34.99. And then what you get would be 6.0017%. So sales tax here is correct, right? 6.0% approximately. So this here, great solution and analysis. Solution here is correct. That was number 8. Let's do number 9. So number 9 is stating, what is the greatest common factor of 8x and 40? So GCF, or greatest common factor of 8x and 40. So when we talk about GCF, it's the greatest common factor, right? It's this greatest common factor. So we basically have to look at these two terms. So let me write this in black. It's 8x and 40. Right? We're looking at these two terms, and we're thinking, what is the greatest common factor of these two terms? So when we talk about greatest common factor, is what's the greatest amount, or the highest number in which that we can divide both these terms by and still get a whole number. So if we look at these two terms here, I have 8x and 40. So again, that's even. Both of these numbers are even. Or I have one x here. Actually, let me look at the variables first. So 8x and this is 40. So in this case, my variables here, I only have an x on the first side and not on the right side, which means that cannot be a greatest common factor because it's not common. It's not common between the two terms. So x would not be the correct answer. So now we're just analyzing the numbers here with 8 and 40. So 8 and 40, they're both even numbers. So we can divide both sides by 2 here. And we get 8 divided by 2 is 4. 40 divided by 2 is 20. So this is a common factor, but is it the greatest common factor? Is there a bigger number that we can divide this by? We can, right? So 2 here is a common factor. So let me just list these common factors out first. Let me do this in black, actually. So 2 it divides evenly to 2 into 20. That's good. Afterwards, can we? Is there another number? Remember, they're both even, right? So let me try more even numbers. So 8 divided by 4, 4 divided by 4. 8 divided by 4 here is 2. Or sorry, this number was 4. 8 divided by 4 is 2. 4 divided by 4 is 10, right? So which is therefore 4 is also a common factor. That's good. And then is there a bigger number that we can kind of try with this? The next one would be 6, right? In terms of even numbers, and if you can kind of already guess, 6 is actually not a common factor because 8 divided by 6 doesn't give us a whole number. It gives us, I believe, 1.33. So let me skip 6, and I'm going to go directly to 8. 8 divided by 8 obviously is 1. 40 divided by 8 here is 5, which means both of these guys have a common factor of 8, right? And this here will be my greatest common factor. And why is that the case? Well, my highest number here is 8, which means the highest number, greatest common factor has to be basically this maximum of this number, or could be the maximum of this number, right? Which means, therefore, the greatest common factor in both 8x and 40 is equal to 8. So we have the numbers 8x and 40. Since 8x and 40 can be written as 8x equals 8 times x, and 40 equals 8 times 5. Therefore, the highest factor in both the numbers are 8. Hence, the greatest or highest common factor of the given number is 8. So the solution here is correct. Correct. Good analysis. So this was number 9. Oh, okay, let's do number 10. I'm not sure if I have included. Oh yeah, I have. Okay, I have 11 questions actually, so maybe we'll do an extra one today. So it says, what is the square root of 256? So the square root of 256. Let me redraw this. And I'm going to assume that they're going to look for exact values here. So square root of 256. What is the square root of 256? So what we can do first is, again, when we're breaking up this radical, if we don't know what the square is, what we can do is we can simply just divide, or we can find what a factor is of 256, right? In this case, it's an even number, so I'm going to take out 2 first here. So this will equal root 2 times root whatever 256 divided by 2 is. So 256 divided by 2 is 128. So 128. So now what we can do is we can do the exact same thing, and we can take this out as well, right? So let me take 128 out. Let me take another root 2 times root 2 times. So I'm dividing again 2 by 128 here. 128 divided by 2 here is 64. That's great. This here is 64. And I know I can now simplify kind of these two terms, right? Root 2 times root 2 obviously equals simply just 2, right? So I have 2 times root 64. And now it actually looks very, very easy, right? I actually know the square root of 64, right? If you know from your kind of your squared multiple, your squared numbers here, 8 squared here is 64. So 8 squared, if I know that, if I know that 8 squared equals 64, therefore the root of 64 equals 8, right? So this is simply just, this is equal to 2 times 8 here, right? Because I know that root 64 equals 8, therefore my answer here is 16. So 256, the square root of 256 here is 16 here. But what if I didn't know the square root of 64 was 8? What you could do is, again, you can do the exact same thing here, and you can do 2 root 64. So I can separate 64 again into 2 parts here. So I would have, again, 2 times root 2 times, and then whatever 64 divided by 2 is, which I believe is 32. And then I can do the exact same thing again. I would have 2 times root 2 times root 2, and I would get root of 18. Or sorry, 16 here. This would be 16. And this would equal just simply 2 times 2, right? Square root of 2 times square root of 2 is root 2 times root 16. And by then you would know that's 4 times root 16. And this is simply just 4 times 4, which is 16. So again, this here is the square root of 256 is simply just 16. So it's a perfect square, which is very, very nice to us. So this here is 16. So how did they solve this? So taking the square root of the number is exactly the opposite of taking the square of the number. That's good. And then what they do is the given number 256 is a perfect square. The perfect square is a number whose square root gives a whole number. So this here it's actually plus or minus 16 if you want to be really specific. So let me just write that down because it's actually plus or minus 16 here. So here's plus minus 16. That's good. And then they did some other stuff here. So this solution is correct. Our solution is correct. Good analysis here. So again, they have a perfect square. So this is actually a very easy question to solve. It's actually a perfect square here. Okay, so now finally, let's look at number 11. And I guess this will be our last question of the day. We'll end our video slightly early today, but we got over a lot of questions, so that's good. Most of them are pretty easy though. So it says 3 to the what power equals 243. So 3 to the what power equals 243. So what we can do with this one is what they did was the answer was 5. So their answer was 5, and they actually wrote down an equation, and they kind of used this guess and check method. So let me just I'll write their solution first, and I'll write down a cheat way. If you're in higher mathematics, you would definitely not use trial and error here. So I have here, the equation here says 3 to the what power, I'm going to say it's x equals 243. And what this University of Toronto Scarborough student did, which was actually really good, is they did a guess and check. So they're saying, okay, so I'm saying if x here equals 2, then it's going to be 3 squared, which equals 9. If x equals 3, then I'll get 3 cubed, which equals 27. And then x equals 4 would be 3 to the power of 4, which equals 81. And finally, if it was x equals 5, which is 3 to the power of 5, which equals 243. So now, because I guessed and checked it, and I know that 3 to the power of 5 is 243, so therefore 3 to the power of 5 equals 243. So that here will be my correct answer. That's what this student did here, which is good, because in grade 9 mathematics and in kind of pre-algebra, that's the only way you know how to solve for these exponents, right? However, if you were kind of pursuing higher level mathematics, you actually know that you can use this topic of logarithms to solve for this problem here, right? What I can do, and I'll do this in red, And this isn't expected in grade 9, obviously, but if you were curious as to how to not do guess and check for these guys, because sometimes they don't come up to nice numbers, is if you have 3 to the x equals 343, what you can do is take the logarithm of both sides, right? So the log of 3 of this number, 3 to the x, equals the log of 343. So basically, I'm taking the logarithm of both sides. What I can do based off my logarithm rules is I can move this x to the power of, and I can actually bring it down here. So x becomes x log of 3 equals log of 343 here. And to find x, I would have to simply move log 3 to the other side, right? X would equal basically log, or this is 243, not 343. I don't know why I wrote that. This is 243. Log of 243 divided by log 3 here. And this will get actually exactly, this here would give you 5 if you type that into your calculator. So let me just double check that. 243 divided by log of 3 will give you exactly 5. So this here is a foolproof way to solve for the solution here, just because you don't have to guess and check as much. You're not expected to learn logarithms at grade 9, but this here is, again, probably what you learned about grade 11 or grade 12, where you take this concept of logarithms and you can actually find what to the power of equals 243. So again, both of these solutions are correct. You can use this way is a guess and check. This here is a guess and check, which is good for, again, I guess, grade 8 and grade 9 math. You know how to guess and check here. You know kind of the square answer. You're just simply multiplying by 3 like this, 3 like this, and 3 like this till you get an answer. And then, again, in grade 11, grade 12, you learn this concept of using logarithms here. So that's going to conclude my video for today. Let me just verify the solution really quickly. Explanation, the equation of the question is 3 to the power of x equals 243. So what they're doing is they're doing guess check. So they did exactly the same thing as I did. So therefore, 3 to the 5th power equals 243. So great guess and check. So I'm going to say correct solution. And great guess and check method. You can also use logarithms to solve for this problem, but for the scope of a pre-algebra and algebra 1 course, this would be a perfect solution. Because again, as a grade 9 or as a grade 8 student, you would not know how to use a logarithm. So this solution here is correct. That's going to take me to the end of my video for today. We're going to end slightly early, but that's totally fine, just because we did breeze through by all the questions that I've prepared for today. Again, if you like this video, again, just definitely give OneClass a follow on YouTube. You can follow them on youtube.com/OneClass. And you can feel free to check out my live streams. Again, I stream from basically Monday to Friday. I stream math Monday, Wednesdays, and Fridays, and I stream chemistry on I stream chemistry on Tuesdays and Thursdays. So you can come check me out then. Again, if you're in the chat, thank you for watching. And again, the important thing here is to stay safe, stay healthy. I'll see you in the next video. Take care.